Hello there and welcome back. So we are continuing from the previous episode where we ended at blinking the LED. In this episode, I want to teach you how you can read the state of a button and use that state to control the turning on and off of the LED. So let's go to your user manual and scroll all the way to the table of content. Now, okay, let me use this image. Yours might be different, but most development boards from ST Microelectronics comes with at least two buttons. The blue one is user controllable, which means you can read the state of that button and use it to determine when a particular action is performed within your firmware. And the black one has a fixed functionality. It is for resetting, so once you press it, the firmware execution is going to be restarted. So our target here is to learn how to control this button, like read the state of this button and use it to control the LED that we have selected. And that means we need to read about the buttons section. All right, so here it says B1 user and wake up button connected to IOPA0. So this is port A, pin 0. And B2, which is the reset, is connected to NRST and is used for resetting. So our target here is B1 user and it's connected to port A, pin 0. So what it means is that we need to configure pin 0 on port A as an input. And I have also looked at the schematic for my board and I know that this pin is connected as a pull down. What it means is that when the button has not been pressed and I read the status of pin 0 on port A, I'm going to read a low. However, when the user presses the button and I read the status of this pin, I'm going to get a high. Let's see how to translate that into code and use the status of that button to control the LED. All right, so here we still have to make use of this GPIO init type def that we use in the previous episode, but we don't need to declare another instance. We can actually reuse it by changing the fields that we want to change, because after we have called this HAL GPIO init to already configure the pin on port E, we can change some of the fields and use it to configure another port. So I'm going to say cfg.mode is equal to GPIO mode input. Okay, so this says we are configuring that the particular pin as an input, and then now we need to talk about the pin, right? And we know that it is pin 0, so GPIO pin 0. All right, cool. So now we have to call HAL GPIO init for GPIO A, and we pass a reference to CFG. So this is how you get to reuse the GPIO init type devs. So you use it, you configure it for a specific pin, and you use that to initialize the pin on the port, and then you can change the fields that you need to change to be able to use that to configure another pin on another port. Now, you also have to remember that because you're going to use GPIO-A, we need to enable clock access to that. And I'm going to copy this because I don't like IntelliSense from this IDE. So I'm just going to copy that, paste it, and change GPIO-E to GPIO-A. So this essentially enables clock access to GPIO port A. Otherwise, everything we do is not going to work. I'm going to get rid of this, and then I'm going to check if you call the function HAL GPIO read pin, and we are reading from GPIO A and GPIO pin 0. Okay, if it's equal to GPIO pin set. Remember, I said that if the button is not pressed and we read the pin, we are going to get a low. But if it is pressed, we are going to get a high. A high is represented by this macro GPIO pin set. You can see that it has the value 1. and GPIO pin reset has the value 0. So when it is pressed, this portion of the code is going to execute. So then here we do HAL GPIO write pin, and we want to write to GPIO E because that is where the LED is connected, and it is on GPIO pin 9, and we want it to be in GPIO pin set. So we basically turning it on. Otherwise, let me just copy this. And then I'm going to set it to reset here. Yes. And just to give the processor some breathing space, I'll call HAL delay, and I'm gonna put 50 milliseconds here, so it's gonna sleep for just 50 seconds. All right, so this is how we do that. I'm going to compile this code by clicking here. Hopefully everything works as expected. And yes, compilation is done. So now I can click to load the program onto the microcontroller board. And waiting. All right, so download verified successfully. So the code is now on the board. I'm going to switch to the bench. And here you can see that the LED is neither on nor blinking because the button has not been pressed. Sorry. So I'm going to press this, and you see that as long as my hand is on the button, the LED stays on because the portion that reads the state is reading a high, and that is the part in our code where we are setting it to be turned on. Okay, when I release, it goes off. I press, it comes on. I release, it goes off. I press, it comes on. I release, it goes off. So this is how you read the state of a button and use it to control stuff. But this is problematic because buttons inherently have a problem known as bouncing, and I'm going to show you how you can do debouncing in a later video. But the best way to do what we did is to use what is known as interrupt. So we will also talk about interrupt in an upcoming video. So I'm going to switch back to the desktop so you can see the code one more time. And it's not bad, it's not daunting, it's not difficult to understand. Thank you very much for watching this, and I will see you in the next video.